Okay, in today's lesson, we're going to look for the percentile and the cutoff value. For any percentage of the data, there is a corresponding percentile or cutoff value. That is the value that leaves the given percentage of the data below it. We might given the percentage and needed to find the cutoff value or the cutoff score. The cut score, note that the percentile is the cutoff value, not percentage. So if they say in 17 percentile, that means in this value, 70% of the data is going to be below this specific value. So how do we find it? We are going to use GeoGebra. Let's just use some examples. In here, let's continue the rainfall, which is we have 40 inches with a standard deviation of 8%. The lowest 10% rainfall. So that means it's approximately here. This is the 10 percentile of the data. And we want to know what is this value on the number 9. So let's pull out GeoGebra. And then we will change the mean and the mu, 40 and 8 for sigma. So in here, you want to be less than. What? 10%? So that means your value, your ended value. So in here, now is negative infinity. We don't know what we're looking for, but we can choose the outcome because the outcome, the equal to, we want it to be 10%. So look, this highlighted part is going to be 10% of the total area of the bell curve so that we know that the cutoff value, we can read it in the parentheses, which is if the rainfall is less than 29.74 inches, it's going to be the lowest 10% of the rainfall. So now, okay, now, next questions. Oh, sorry about that. Okay, a child has, oh no, it's here already. And now the highest 5% of the rainfall. The highest 5%, that means you want the data, the shaded area, is going to be on the right side, which is what I pointed with my cursor. And then also 95 percentile. Okay, so go to GeoGebra. It's greater than, that means we need to switch the x. And this time, we want the highest 5%. Remember, 5% is 0.005, not 0.5. 0.5 would be 50%. So in here, it's going to be the highest 5% of the data, which is at 53 inches. So you might write it down by yourself, or you can also use the 95 percentile, which is the shaded area, which is going to be 95 percentile. You also get the same solution, which is 53.158. So either way works, they will automatically switch for you. It depends how you comprehend the problem. There's multiple solutions. Okay, so the middle 50% is a little bit tricky. How do I guarantee, like even though in here, how do I guarantee they won't let you put in 50%? Because it's hard to find that 50%. The middle 50%, you don't know from which part. Now, I'm going to show you how to find the 50%. So here is the idea on how to find the middle 50%. So we know that the first standard deviation is going to be 68%, so it should be something in here. Okay. If the green part is 50%, that means whatever outside on the two ends is going to be also 50% because the total area should be 25%. That means my orange part, oh, that's not orange, this is orange. The orange part is going to be the highest 25%. And my pink, oh, they changed it to pink. I want orange. And then the pink, which is here, is going to be the lowest 25%. On the other hand, the pink one is going to be the 25 percentile. And the orange one is going to be 75 percentile. So we can use that to find the cutoff value in here and in here. Okay, here's GeoGebra. How are we going to do that? Let's find the highest 25%. So the highest 25% is going to be on here. In the highest 25, we can choose 25, which the cutoff value is 45, 39, 45.39. So now I'm going to write it down. Here, the highest one is 49.39 inches per year. Now, let's find the pink one. Use the similar idea. You want to find the lowest 25%. That means I want to change that to the lowest 25%, which gives us 34.6041. Okay, now I write it down. I have 34.6041. So that means in between that, X is going to be 50%. That is going to be the middle 50% of the rainfall. So your answer should be the probability X follow normal distribution with mean 40, sigma is 8, and then 34.6041 to 49.39 is going to be 50%, the middle, exactly middle 50% of the data. Okay, and that's it for this video, how to find the cutoff value.